Hi, I'm Andrew Armstrong. Welcome to the back office teardown lab. If you recall, we have a BMW/Range Rover DSP amplifier with some corrosion here, and in fact I've just noticed a little bit of extra corrosion on this pin here. In that video we went through and we cleaned it all up. However, I did notice, I've just noticed this, that's better, that one of the pins here has basically corroded away totally, and I was hoping it didn't do anything, but it does have function and it does other stuff on the board, so I'm assuming we're going to need that for this to be working. Could be why this isn't working. The problem is I don't have a replacement connector, so we're going to do for the first part, which will be the same way as if you've got a replacement connector, how you're going to fit it, but for me I'm probably going to repair that pin itself, so that'll be a bit interesting for you. Or it'll be a big failure for me, one or the other. I'll probably just take this off and ruin it totally. But let's see. So the first things first is it's covered, absolutely caked in conformal coating. And it's not the soft silicone type that might just wash away with, chemicals. It's the sort of hard resiny type that's gone gross over the years. So just very gently pick this out. And the reason you want to be gentle is, of course, there's PCB traces here, and if you knacker them, then you're making a lot of extra work for yourself, or possibly even ruining the board. So just be cautious here. So I've got my little tweezers here, which I'm abusing by picking out this gunk with it. And my technique really is to just work my way around the edge of each pin. And these tweezers have a little hand on the end, which is nice, a little hand. So I can kind of just do a little pinch, like a very mini pliers, a micro pliers. And if I'm lucky, that'll grab a bit of this gunk and then just sort of force it off. But be very careful, don't dig too deep. Just even then I'd sort of dug a little bit too deep, and I can see I've taken off a tiny bit of the sort of varnish on the PCB, but that should be okay. So that's the worst of it, and that's the in-between bits done, because they're sort of harder to get to. In fact, one more there. Yeah, I'll just show you what I'm digging at. Bit too far zoomed out. You can see there, sort of a bit shinier is where I've gone a little bit too much. So I'm just going to try to sort of clean up each one. So you can see I'm just sort of grabbing the sort of pin, and then I'm twisting, and that's pulling off the little cap of resin that's gone on there. I'm just really eyeballing this up now. Sorry, I'm engrossed here because I'm just seeing is there a damaged trace or not. Probably not. Finding a circuit diagram for this is going to be near impossible, so don't do anything that you can't repair. And if you can, take a bunch of pictures before you start. So I'm just using a very gentle steel brush here, and I'm doing it gently because I want to sort of clean this off as I go through. But again, you can really see those shiny traces in there. That's the bit that's giving me a little bit of concern. Just want to be gentle around there. If there is a trace there, I need to know so I can rebuild it. Good. That'll be a microscope job, so we'll have a look at that in a moment. Now we've got this really big gunky part on here. Again, you can hear the scraping. Get in there. Flick that bit in my eye. Thank you very much. Yeah, I think that's just ground plane in there, so that's okay. Phew. Now there's a lot of revision to this board, so don't take my word for it. On my one it happens to be ground plane, on yours it might not be. Just be careful. Let's have another dust off. Good. It's looking real nice. So let's look closely. So you can see most of them are just plain, That's a real pin with a trace, that's a real pin with a trace, and the rest don't. So that means their circuits lie on the top, and you can see them quite clearly there. That's good. So you've got these two big contacts with those big lugs that's holding that on. So there's all sorts of techniques you've got. You probably, most people would say, use a solder sucker. Use a solder sucker. For me, I've never really got on with a solder sucker. I found it doesn't work, and you end up mashing whatever you're trying to take off. So I'm not going to probably use a solder sucker. I'm probably going to try some hot air. I'm a little bit concerned though that there's still quite a lot of gunk on these, so I'm not sure how that's going to affect it really. I kind of think it will certainly not help the process. And then before I do that, I'm just thinking to myself, if I needed to repair a pin, is that the best way of doing it? I think so. I don't think you've got really any option apart from taking this out, because you want to mechanically try to remove the pin to repair it back in. And there's no way you're going to get it out without getting the pin that's blocking it off. You'll see when I get in there. Let's just do it. So I'm going to apply some flux. Not much left of my gel flux. The best flux, the good flux. That should be enough. And a lot of heat and a lot of noise, so do bear with me. Just getting up to temperature. Try not to put too much heat on this connector, you don't really want to melt it. Just trying to work out when it goes molten, I might try to push it down with my thumb and then lever the PCB up with the rest of my hand. That seems to be cooking the conformal coating. Maybe that's a good way of getting it off. Bit of heat. These guys might need actually to be actual solder sucked off, because I don't think they're going to react properly. They're drawing way too much heat. Whew. Okay. Let's just check that out. We don't want to waste our time on those. Can't. Yeah. Ah, hang on. Phew, lucky we did that. I think these are bloody pop rivets. Solder sucker. Yes. Phew. Lucky we checked. Okay, you spend forever trying to get those out. I need to get a drill and drill the heads off those. Go, that's one. Watch the PCB with your pliers. Just pull straight up so you don't scag anything. Good. Right, we'll put some screws in there when we're done, but let's get back to it. Definitely getting molten now. Woohoo! Okay, that was horrible, and I kind of melted this a bit, so that's going to need a little bit of repair. But that's just plasticky stuff. That's going to be a bit of Dremel action. Let's not worry about that though. Let's have a look at the PCB, see where we are with that. Focus. Let's see. So the only bit that's kind of giving me a little bit of concern is this ground plane in between. So you can see here there's a ground plane. Just because when we're soldering stuff there's a chance that we'll put a blob of stuff onto there. So if you really are concerned, I think I'll be alright. I'll be able to check that afterwards. You could just scrape it away basically from in between the pins. But the pins look okay. It's giving them a little clean. That's okay. Let's see this side. That looks good too. Something to note. 1, 2, 3, 4. So if we look at 1, 2, 3 in from the end and those cluster of 4 pins. 1, 2, 3 in from the end and those cluster of 4 pins. Look, this pin, 3 in from the end. They're not being used, are they? 3 in from the end. So it means we could probably transfer one of the pins from there to there in the connector. So let's think about that. So that goes in like that, and we're talking 3 in from the end. So like this pin we could remove and swap that out. And you can see where I've mauled this, and one of the pins has come out. It's just basically a metal pin, and it's just wire, basically square wire. So it's all a bit crusty, but to get to it, I'm just checking the end now. The pin I've got to replace is the 5th pin. 1, 2, 3, 4, 5, this pin. So to get to this pin I'm going to have to remove that one. And just have a check. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Actually its counterpart pin isn't used at all. So that's slightly, I'm not saying risk free, but less risky, because if I mess up the outer pin, the 5th pin down, 1, 2, 3, 4, 5, this one, there's the chance, of course, it won't affect my circuit. So that's good. So I'm just going to try to work my way with this blade, but no, this is a thermo setting plastic. It's bloody hard. So 1, 2, 3, 4, 5. Just applying a tiny bit of heat. We saw that heat affected it. Come on, get away. Get away from me pin there. So that's the pin I want. So I might have to go and have a look in the old toolbox for along those pliers. Again. Just double check. Always double check. 5th from the end. 1, 2, 3, 4, 5. It's that one we want. So if I bend it ever so carefully to make it straight, and if I'm lucky, it pulls right out. There we go. Good. Now let's get to the one. This is our damaged one. It should be considerably shorter. I'm really kicking myself for misplacing my long nose pliers. There we go, that's the one we want. Boom! That's super short. Good! That's excellent. I think we're making some progress here at last. So this is the pin though that kind of got knackered, and the reason it got knackered, this is the one when we were taking the connector off the board, is it had this little dog leg, see it there? And that was hooked over on the PCB, so it obviously strained it as we were pulling that out. So that's when someone's basically cut the pin on the PCB, and it's just got that little bit sticking out. So I want to push this one back in, and unfortunately the hole that's supposed to go in has become deformed with the heat. So this one's going to be probably more of a challenge than the 2 we just extracted. But let's see if we can get that on there. Push. Yeah, that one's going to need me to sort of drill that hole out. Right, I'll clean that up and then we'll get back to fitting these pins. Just tapping in a micro drill bit because it's harder than the material to clean that hole out, because if you recall, that's the bit of the rusted off broken one. Let's get that right through. Yes, connector now is clear. So what I'm going to do is very cautiously, very quickly, if you remember, we have to remove one of the pins. It was that one that was broken, but checking the PCB, that wasn't connected to anything. Hooray! So it means we have this one to play with. That's all. The only one we've got to fix really is that one, because that was the bit that was actually connected to something. So just poke that in. It's really soft, this material, so be careful. It'll probably break, bend or something. This one's already bent several times now, so it's liable to snap. Ooh. It's starting to go through, but it is also starting to bend. It really is a soft wire, this soft. Almost through now. Let's be gentle with it, I think that's the only thing you can do. That's it, that's through. Yes, looking good. So the rest, again, sanity check. Always keep sanity checking. 1, 2, 3, 4, 5. Yeah, they're not connected. How lucky, ever so lucky. It's just a case now of just bending these all correctly so that the header will go back through the PCB, so we can solder it all up. Of course, this is the outer, this was sort of donated from the outer pin, so it's going to be a bit longer, but that's not a problem. The only problem is actually it's a little bit weak. Looks like it's about to snap off, so I'm going to be really cautious with that. Let's try to get the other ones squared up. They're looking good, so just gingerly start offering that back in. Yeah, that's all going to be pretty good. So what I'm going to do is just trim all these, but just sort of rub them with a soldering iron and just clean them all up, and I'm going to clean this gunk off with a bit of sandpaper, and then we'll solder it all back on. Push the connector through, nothing too interesting about that, just make sure that you kind of align all the pins and you're not forcing anything where it doesn't want to go. They look like they've all more or less surfaced, and then just apart from the 2 missing pins, which are outer pins. So if you remember, we took those rivets off. I couldn't find any self-tappers, but I got a couple of wood screws. It doesn't look like they're going to foul anything, so I'm just going to put those in, and if they do look like they're going to foul something, we'll just take them back out again. That should be fine. So the reason I'm putting this in first is because it will help us locate it. It's basically, yeah, nice. It's screwing itself into the sort of meat here of that thing, so it's basically creating its own thread in there. Self-tapper would work really well too. If this doesn't foul anything in the case, it's not going to be a problem. You can always remove them after you've soldered if you think it's going to be an issue. But yeah, that's nice and tight actually. Yeah, that works. That works pretty good. Good. So I'm just checking again, just double check everything looks poked through. There's one there that's definitely sort of sitting proud, this guy, this pin here. It's kind of bent basically as this went down. The rest are alright. So its hole basically that it was going into was probably a bit fouled. I'm just going to give a little bit of extra attention to that one individual pin. So all I'm going to do is from the top here, I'm just going to heat it and just put a touch of solder on it, because the solder's got flux in it. Not only does the solder have flux in it, but when the solder flows, it lets the heat flow a bit nicer to it. Just about get in there. Yes, I can. It's not so easy to get into, but just I'm heating that there, and I'm just going to push down. There, it appreciated that. You could hear it sort of wire bending, getting into a better position. And this one here also looks like it could benefit from the same treatment. Yeah, that's nice too. Good. There, so they're all going now. Let's flip that over. And we've got one mega long one, which is good. That's our mega long one that we repaired. I just want to check that's still good. We'll cut that off at the end. It was looking a bit fragile, if you recall, because it's just a lot of reused wire being bent over and over and over again. So we'll cut that right at the end. And I'm just giving these a bit of loving attention, each one. I'm holding it on there for a bit longer because I want to be totally satisfied that the capillary sort of action has drawn the solder through that via, so it's gone down to the other side. And that's good there. Now this is our new one. I'm going to try to put a little bit extra because that pin was a bit weak, as I said, so I want it, if possible, to go right down through there and basically adds a layer on the outside of the pin, makes that a bit thicker. That's looking good too. Missing pin, we don't need that one. It's nice and calm now, isn't it? Taking my time. Missing pin. That one drew quite a lot of solder down. You can hear these like noises, like ticks and bumps. That's the mechanical noises of the connector. It's when you heat it, it's basically relieving the stresses that it's sort of endured by screwing it onto there before it was ready. Let's have a look. Turn it over. Yeah, we got little pools of solder on the top, which is absolutely fine. That's actually a bit more reassuring, if anything, for me. That connector's pretty solid now, so we can cut away that extra bit there. If you've got some side cutters, that's the tool for the job. If you haven't got side cutters, good luck. Maybe go and buy some. And I like to just smooth that over. Good. So if you've got some, now's a good time to sort of spray a bit of conformal coating if you're sure, if you're pretty sure it's going to work. If you're confident you don't need to do anything more with it. Have a check over, have a little clean. Maybe get your brush in there and have a look under it under a scope or something. Or add some flux clean if you really want to go to town. Of course, you'll need to clean it if you want to conformal coat it anyway, which I'm going to do. So I'm going to clean it for sure on my one. But yeah, wang that in the car now. You could probably do a loose sort of assembly. Wang it in the car before you put all the screws in. And if that all works, then screw the whole lot up. Maybe that's a better time to do your conformal coating once you're sure you don't have to do any more work. So that's nicely soldered there. And our important missing pin is in there, and we've removed 2 pins that were not important. So yeah, that's probably a good repair. That saved me probably, I don't know, 100 quid or whatever it costs for that board. Nice one. Hope that's some use to you. Sorry about the babbling again. Jet lag, a bit messed up. If you do want to replace this, actually, I'm just reading it. There is a part number. Let me get that for you. It's a Tyco 963539. That's Tyco 963539. There's also another part number, strangely enough, which is 962748. 962748. So maybe you need both of those, who knows, but that's that part. You can just get that. If you've got the time, just replace that. Don't worry about the pin thing like me. Thank you very much for watching, everybody. Bye bye.